Welcome to homework.
Total energy absorbed by the tissue should be equal to the total energy that was emitted by the photon according to conservation law. So therefore, have energy is equal to hc of lambda times n. We know h is Planck constant, which is equal to 6.63 times 10 to the power negative 34 kilogram meter squared per second. And we know c is the speed of light, which is equal to 3 times 10 to the power 8 meter per second. Wavelength is given as 0.02 nanometer, which is 2 times 10 to the power negative 11 meter. And we know the number of photons is 5 times 10 to the power 10. So now let's plug in back to the equation to determine the total energy that was absorbed by the tissue, which is equal to 6.63 times 10 to the power of negative 34 kilogram meter square per second times 3 times 10 to the power of 8 meter per second over 2 times 10 to the power of negative 11 meter, and then times the number, which is 5.00 times 10 to the power of 10. And this will give us the total energy that was absorbed by the tissue should be equal to 4.97 times 10 to the power of negative 4 joule, which is equal to 0.497 millijoule. So now let's try to determine the equivalent dose. First, let's determine the absorbed dose. So the absorbed dose in rad can be equal to energy divided by mass. So we know energy is 4.97 times 10 to the power negative 4 joule, and the mass is 0.6 kilograms. So now let's plug it back to the equation to determine the absorbed dose in rad first, which is equal to 4.97 times 10 to the power of negative 4 joule divided by 0.600 kilograms. And this will give us the absorbed dose is equal to 8.29 times 10 to the power of negative 4 joule per kilograms. But remember, the let me show you. 1 joule per kilogram can be equal to 100 rad, since 1 rad is equal to 0.01 joule per kilogram. So now let's convert it to rad, and this will give us the absorbed dose in rad is equal to 8.29 times 10 to the power of negative 2 rad, which is equal to 0.0829 rad. So now let's determine the equivalent dose in rad, okay? So we know the RB for the X-rays is 1 rad per rad, and equivalent dose in rad can be equal to RB multiplied by absorbed dose in rad. So now let's plug in back to the equation to determine the equivalent dose in rad, which is equal to 1 rad per rad multiplied by 0.0829 rad, and this will give us the equivalent dose in rad is equal to 0.0829 rad. And these are the answers for this question.